Hi everyone, in this video I will explain two PYQs which are based on Vandermonde's identity. See one PYQ, if 30C 30 minus R plus 3 into 30C 31 minus R plus 3 into 30C 32 minus R plus 30C 33 minus R is equal to NCR, then the value of n is. So it is numerical value type. Answer is 33. Problem given on April 2nd 2026 in shift 2. Now see the procedure. So I am writing left hand side of the given equation. So I am writing 1 into, instead of writing 30C 30 minus R, I am writing 30CR. By using the property NCR is equal to NCN minus R. Next coefficient 3 I am writing same. 30C 31 minus R can be written as 30CR minus 1. Again this 3 also written same. 30C 32 minus R can be written as 30CR minus 2. Last I am writing 1 into 30C 33 minus R can be written as 30CR minus 3. So each binomial coefficient is modified with the help of the formula NCR is equal to NCN minus R. So in place of 1 I am writing 3C0, that is multiplied with 30CR. So in place of 3 I am writing 3C1, that is multiplied with 30CR minus 1. In place of this 3 I am writing 3C2 multiplied with 30CR minus 2. So in place of 1 I am writing 3C3 multiplied with 30CR minus 3. So the given series was not in the standard form. I modified the given series into standard form. Now this series is having what properties you know? In the first term sum of the lower indices 0 plus R becomes R. In the second term also sum of the lower indices 1 plus R minus 1 R. In the third term also R. In the fourth term also sum of the lower indices is becoming R. So that series is having the property in each term the sum of the lower indices is R. Then how we can calculate the value of the series? See the procedure. Now we are considering group A containing 3 dissimilar objects and group B containing 30 dissimilar objects. Consider two groups. One group containing 3 dissimilar objects, another group containing 30 dissimilar objects. To get the given series, just I am calculating the total number of selections. Each selection is containing R objects. See by method 1 how I can calculate. Let us consider case 1. From group A, no object is selected. From group B, R objects are selected. So such a number of selections will become 3C0 multiplied with 30CR. From group A, no object is selected. From group B, R objects are selected. So number of such selections will become 3C0 into 30CR, that is case 1, plus 1 object is selected from group A, R minus 1 objects are selected from group B. Number of such selections will become 3C1 into 30CR minus 1. See the next case. 2 objects are taken from group A, R minus 2 objects are taken from group B. So number of such selections will become 3C2 multiplied with 30C or minus 2. Last possibility, group A containing only 3 objects. 3 objects are taken from group A or minus 3 objects are taken from group B. So number of such selections will become 3C3 multiplied with 30C or minus 3. So I calculated the total number of selections each selection is containing R objects by method 1. See, the obtained series is only the given series. Now I will calculate the total number of selections with another method. The total number of objects 3 plus 30 becomes 33. You know, when the total number of objects are 33, the number of ways of selecting R objects from them, that will become 33 CR. So the total number of selections each containing R objects will become 33 CR. With another method, I calculated the total number of selections each containing R objects. Whatever the method may be, the total number of selections must remain same. Therefore, these two numbers must be equal. But the value of the given series, he had given NCR in the problem. Therefore, I can say that NCR is equal to 33 CR. So, equating N becomes 33. So, the value of N becomes 33. That is the answer to this problem. Further, you see, sum of this series, I told 33 CR. That 33 is sum of the upper indices in any term, or is the sum of the lower indices in any term. Therefore, I can generalize that property. So, if the given series is having the property sum of the lower indices is same, directly we can say the value of the given series is equal to sum of the upper indices C, sum of the lower indices in any term of the series. That is said to be Vandermonde's identity. That is said to be Vandermonde's identity. See one more PYQ. Let alpha is equal to sigma k is equal to 0 to n nck whole square by k plus 1, and beta is equal to k is equal to 0 to n minus 1 nck into nck plus 1 by k plus 2. If 5 alpha is equal to 6 beta, then n is equal to dash. Numerical value type answer is 10. Problem was given on January 30, 2024, shift 1. See the procedure. Let us simplify alpha. Alpha is equal to sigma k is equal to 0 to n. nck whole square can be written as nck multiplied with nck by k plus 1. Next, this summation I am writing sigma nck is written same, first binomial coefficient. I am multiplying numerator with n plus 1. N plus 1 by k plus 1 multiplied with nck. So n plus 1 extra factor in the numerator. Therefore, I am taking n plus 1 in the denominator. Now see, second term is converted into the form n by r into n minus 1 cr minus 1, this formula. N by r into n minus 1 cr minus 1, that can be written as ncr. So here k takes values from 0 to n. Let us write 1 by n plus 1 same. Sigma k is equal to 0 to n. first binomial coefficient nck written same. n plus 1 by k plus 1 nck can be written as n plus 1 c k plus 1 according to that formula. So this will become n plus 1 c k plus 1. To convert that series into standard form, let us write 1 by n plus 1 is written same, sigma k is equal to 0 to n, nck is also written same. NCR can be written as nc n minus r, that is n plus 1 c n minus k. Now the given series is converted into standard form. See now, sum of the lower indices k plus n minus k plus k minus k will get cancelled. We are getting n only. For k is equal to 0 to n. That means in all terms sum of the lower indices is becoming n. Therefore, according to Vandermonde's identity, this can be written as sum of the upper indices c, sum of the lower indices. This 1 by n plus 1 is written same, sum of the upper indices n plus n plus 1, that I am writing 2n plus 1. Sum of the lower indices k plus n minus k, just I am writing n. So that is the value of alpha. Similarly, let us calculate the value of beta. For beta he had given sigma k is equal to 0 to n minus 1, that is nck multiplied with nck plus 1, denominator is k plus 2. To convert this into standard form, sigma k is equal to 0 to n minus 1, first binomial coefficient nck written same. I am multiplying numerator with n plus 1. In the denominator let us write k plus 2. Binomial coefficient we are having nck plus 1. So I took n plus 1 extra factor in the numerator. I am taking n plus 1 in the denominator. Again now this is also converted into n by r, n minus 1 cr minus 1, that can be written as ncr. So write this 1 by n plus 1 as it is, sigma k is equal to 0 to n minus 1. First binomial coefficient nck written same, n plus 1 by k plus 2 nck plus 1. This can be written as n plus 1, n plus 1 c k plus 2. Now to convert this series into standard form, let us write 1 by n plus 1 same, sigma k is equal to 0 to n minus 1, nck n plus 1 c k plus 2. By using ncr is equal to nc n minus r, this can be written as n plus 1 c n minus k minus 1. Now this series is converted into standard form. See now sum of the lower indices k plus n minus k minus 1, plus k minus k will get cancelled. So in each term of the series, sum of the lower indices is same, n minus 1. Therefore, according to Vandermonde's identity, this can be written as sum of the upper indices will become 1 by n plus 1 written same, sum of the upper indices is 2n plus 1, sum of the lower indices k plus n minus k minus 1, that becomes n minus 1. So I simplified alpha, also I simplified beta. Let us substitute there. Here given 5 alpha is equal to 6 beta. Now let us consider alpha by beta. Therefore alpha by beta can be written as 6 by 5. For alpha I am writing 2n plus 1 cn by n plus 1 by beta. So because of double fraction, n plus 1 comes to numerator, denominator 2n plus 1 cn minus 1, that had given 6 by 5. There n plus 1 common factor will get cancelled. Now we are having 2n plus 1 cn by 2n plus 1 cn minus 1. This is equal to 6 by 5. Let us use this formula. NCR by NCR minus 1. This can be written as n minus r plus 1 by r. So according to that formula, n means we are having 2n plus 1. R means we are having n plus 1. This is n minus r plus 1 by r. R means we can say n. So this value here given 6 by 5. So in the numerator 2n minus n. In the numerator 2n minus n becomes n, that is plus 1 plus 1, that becomes plus 2 by n. This is equal to 6 by 5. By cross multiplication, 5n plus 10, this is equal to 6n. Taking this 5n to right side, 6n minus 5n becomes n. Therefore I can say value of n becomes 10. So the value of n becomes 10. That is solution to this problem. Without practicing, you cannot improve mathematics. You practice these two problems. For more videos, subscribe.